Hello guys, in this video I will be explaining exponential functions, exponential growth and exponential decay. Let's take a look at what exponential function is. It is a function that can be written as b to the power x. B is a base, which is a fixed number. X is an exponent, which is varying. The exponent is always x and base is always a positive number other than 1. And if we have a coefficient here in front, let's say f of x is a times b to the power of x, that coefficient also must be positive. So if a function satisfies these conditions, then we have an exponential function. We have two types of exponential functions. Let's talk about them: exponential growth and exponential decay. The blue graph represents exponential growth function. We have this function when base is greater than 1. So in this case, our function is rising from left to right. As x values are getting bigger and bigger and bigger, the function is increasing. And for the red function, this represents the exponential decay function. As x values are getting bigger and bigger and bigger, the function is falling down from left to right. The decrease is very fast at first and then slowly. So we have this situation when base is between 0 and 1. And if you recognized, we have a function that's approaching to x-axis. Both of them, exponential growth and exponential decay functions, are approaching to x-axis. Approaching means the graph is never touching the line, never crossing, never touching. So we have a horizontal asymptote here. Asymptote is a line that function is approaching. You studied asymptotes last year. You'll also study asymptotes next year. So this is just a note. It is not. We are not gonna use this year. What we are going to do here is we will learn how to graph exponential functions. You studied how to graph functions before. Now, by using the same techniques, we will graph our exponential functions. For example, let's take an exponential growth function 2 to the power of x. 2 is a base which is greater than 1, so which represents exponential growth function. So the way of graphing a function is using table of values at first, and by using the points in this table, we will plot the points, and by connecting them, we will see how the exponential function look like. So you pick some x values. Let's be careful to pick numbers, the consecutive numbers. It's better to see the basic figure of the function. Let's start from -2. When I pick -2 for x, I substitute -2 for x. 2 to the -2, it is 0.25. If you can't do the basic math, you can just use your calculator. It is pretty simple. -2 for x and 0.25 for y. Here is my point. Let's keep picking some numbers, consecutive numbers, of course. -1 for x. If x is -1, 2 to the -1 is 0.5. So here is my point. -1 for x, 0.5 for y. And the following number is 0. When you substitute 0 for x, 2 raised to power 0 is 1. Every number raised to power 0 is 1. Here is my point. At 0, I'm at 1. And let's pick two more points. We pick two negative points at 0. And let's pick two more positive points. So generally, those numbers are enough for graphing exponential functions. Let's plug in 1. When you plug in 1, 2 raised to power 1 is 2. So at 1, I am at 2. And let's plug in 2 for x. So 2 squared is 4. So at 2, I'm at 4. So now the following step is connecting those points. So when I connect those points, I'll see what kind of function I have. Here I have An exponential growth function. It is increasing slowly at first, and then the increase becomes very dramatic. And about the asymptote here, the function is approaching to the x-axis. When I zoom in, you see that the function is not touching the x-axis. It is approaching but not touching. So this is how exponential growth function look like. So if I ask to graph an exponential decay function, you do the same. You are going to write your function. Let's say y equals, pick a number between 0 and 1, like 0.5. 0.5, close the bracket, and raise to power x. The power is always x. So you use table of values. You can use the same x values, find corresponding y values, plot the points on the graph, and connect the points. By doing this, you will find your function. So here is my function. The red one is exponential growth, 2 to the power of x. The green one is exponential decay function, 0.5 to the power of x. So those are exponential functions, growth and decay. So let's continue and see how we identify exponential functions in the examples. The questions will be: explain whether each function is exponential, and the other type, tell whether the function represents exponential growth or decay. So let's start from exercise 12. X to the power of 10. Is this an exponential function? To have an exponential function, the form is b to the power of x. Base is a constant number. Exponent is x. Is my base a constant number? Exponent is x? No, it is not. So this is not an exponential function. What about 13? Let's take a look at the base. Base is 0, and we also know that we have b is a positive number other than 1. B is a positive number, but here our base is 0. It is not a positive number, so this is not true. This is not an exponential function. The third one, 0.5 is the base, which is a number bigger than 0, which is not 1, and exponent is x, so yes, it is an exponential function. 1 is a base here in the next question, which is not possible. See, base is never 1, so that's not an exponential function. Negative 2 is a negative number. Our base must be a positive number, so that's not also possible. So those are not exponential functions. Only exercise 14, the function is exponential. This was the first part. The second part, we will tell whether each function is exponential growth or decay. Remember, when we have an exponential growth function, we have exponential growth function when our base is bigger than 1. We have an exponential decay function when base is between 0 and 1. So let's check each question one by one. The first one, 0.5 is a base, which is a number between 0 and 1. So we have an exponential decay function. Exercise 3, 1.2 is the base. Base is a number bigger than 1, so that represents exponential growth function. Be careful, don't confuse base with the coefficient. They are totally different things. The base only determines the type of the function, not the coefficient. Coefficient is 32, bigger than 1, but it doesn't represent that it's a growth function. Only the base represents whether it's growth and decay. Here in the fourth one, 3 over 4, 0.75, which is between 0 and 1. So that also represents exponential decay function. And we have three more questions which are different than the others. We have negative exponents, which is not possible. I can't have negative exponents. My form must be b to the power of x. So I should rewrite this so that my exponent is x. So how do I rewrite this? 3 to the negative 2 to the power of x. What is 3 to the negative 2? Remember, when there is a negative exponent, to make it positive, we reciprocate the number and make the power positive. This is the way of rewriting negative exponents. So 3 to the negative 2 is 1 over 3 squared, which is 1 over 9. So 1 over 9 to the power of x. So let's take a look at the base. Our base is 1 over 9, which is between 0 and 1, which represents an exponential decay function. On the next one, we also have a negative exponent. Rewrite it first, make it positive. 1 over 2 to the power of negative 1 raised to power x. So what is 1 over 2 to the power of negative 1? By using the same rule here, we should flip the fraction. It becomes 2 to the power of x. Now, my base is 2, which is a number greater than 1. That represents exponential growth function. And finally, I have a negative base. It looks like I have a negative base here, but I don't know because my exponent is not written in simplest form. So first I should rewrite it to simplify it. Negative 2 to the power of negative 2 raised to power x. Negative 2 to the negative 2, 1 over 2 squared, which is 1 over 4. So 1 over 4 to the x. 1 over 4 is a number between 0 and 1, so that makes this function exponential decay. So the thing is, you just have to simplify the function first if you have negative exponents. For the last question, you might say it is not an exponential function because I have a negative base, but it turns out my base is not negative, it's positive, so it's an exponential function. In this question, you might say my base is 1 over 2, so it's exponential decay, which is wrong because when I simplify it, I got 2 as a base, which makes the function exponential growth. In this one, you might say our base is 3, so it's growth, but that's false because when I rewrite it, I see that it turns out that my base is 1 over 9, not 3. So first thing you need to do is simplify the function, get x by itself as an exponent, and decide whether it's exponential or not. If it is exponential, whether it's growth or decay.